So what we're going to do now is we're going to show how the different splitterators affect the performance of the application. And this will be using the EX14 example, which is going to do a bunch of experiments for different numbers of input words using different approaches to doing the implementation and doing things either parallel or sequentially. Now, these results here are from a test I did a year or so ago, last time I taught the class. And what these results show is that when you have a very small number of items, it doesn't really matter whether you're doing things in parallel or sequentially. In fact, quite honestly, when you have a very small number of items, doing things sequentially is often a win because n times q isn't big enough to make a parallel, make an impact difference on parallel performance. It doesn't improve things. And then as you get larger and larger, what we would like to be able to see is that when you get a large number of things, then the array list implementation should be a little faster than the linked list implementation because the array list, as you may recall, splits better than the linked list does. So that's what we'd like to be able to see. So sometimes we get this result, sometimes we don't. That's the wonderful thing about benchmarking. So what we're going to do here is show how the splitterators for ArrayList and LinkedList partition up the data in different ways. As we saw before, the ArrayList does this by splitting things in half and doesn't copy the data. So it should be a little bit more efficient, we hope. Whereas the LinkedList splitterator doesn't split evenly and efficiently, and it does copy the data. So there might be more overhead. Again, your mileage will vary depending on all kinds of low-level things in your operating system and your hardware and your memory and so on and so forth. And of course, your Java implementation. So this particular example is going to use an array list and a linked list when processing the complete works of Shakespeare, because why the heck not? And so what we're going to do here is we're going to have a list, which is either an array list or a linked list, depending on whatever you pass in. It's treated as a list here. And then down here, we're going to split and uppercase everything using a splitterator that's either going to be in parallel or sequential. And then we're going to map everything to uppercase and convert it into a list. So we can conditionally select whether it's parallel or sequential. And then we go ahead and put this into a list as the result. So let's go ahead and take a look at what we get as the result. So here we are in the EX14 project. Let's go take a look at the EX14 class. You can see here we've got the complete works of Shakespeare, which is in one file, one very large file. And we have a regular expression. Check this out. This is kind of fun. This is a regular expression that's going to split the works of Shakespeare up into the words of Shakespeare. And it does this by basically matching white space and punctuation and ignoring all of that stuff. So we'll see how that works here in just a second. It's kind of a fun way of splitting things up into chunks. When the test runs, it's going to get the number of processor cores. In fact, let's go ahead and run this thing because it takes a while to run. So it's going to print out the number of cores available. As I mentioned before, not all the cores will be used for this test because there's a core that's recording this lecture, but you'll get the basic idea. First thing we do is we warm up the fork join pool so all the other tests will be hopefully more consistent and accurate. And then we're going to run the Spliterator tests. So let's go ahead and see what happens when we run Spliterator test. So what we're going to do is we're going to generate 4 different values of words, starting with 1,000, 10,000, 100,000, up to 1 million. There's 800,000 or so words in Shakespeare, believe it or not. And what we're going to do then is for each of these values, 1,000, 10,000, 100,000, 1 million, or less than 1 million, we're going to go ahead and get that many words from Shakespeare. So to do this, we're going to call this getInput method, passing in the file, the Shakespeare file, the regular expression to split the works of Shakespeare up into words, and the limit of the number of words of Shakespeare we want. So to do that, we open up the file. That's this file here. We get a path name to it. We open it. We read all the bytes in the file. So now we've got one giant string containing all the bytes of all the words in Shakespeare. We then take that crazy regular expression that I showed you before, and we split the works of Shakespeare up according to that regular expression, which means it's going to ignore all the things that are white space and punctuation. And we then split it. We split the bytes as a stream, so now have a stream of words. we get rid of any empty words, and then we only take that many words, strings, and then we go ahead and we collect this thing into a list of string objects. And I could probably replace that with just a toList as opposed to collect toList if I wanted to. So what we do now is we then create a linked list from the array list. So we take the arrays that we got back here, which is an array list implementation, and we turn it into a linked list implementation. So it kind of wraps that array list with a linked list. And now we're going to go ahead and run the test. So you can see here we're going to call time stream uppercase with a linked list for all the linked words sequentially. We're going to do the same thing for the array list sequentially. Then we're going to do it for the linked list in parallel and the array list in parallel. And then we're going to print all the results. So here's what we're going to do. Every time this thing gets called, it's going to garbage collect. So we start out with pristine state. Keeps track of whether we're doing this sequentially or in parallel. And then we're going to iterate some number of times, because we want to try to make this thing run long enough to get some interesting results. And that, I think, is something like 10 or whatever. Let's see what it is. Yep, oh, 30. 30 times. And each time through, we're going to turn it into a parallel stream or a sequential stream, either way. And then we're going to take each string and we're going to rot13 it, which is just a fancy way of being able to just do some computation to touch the bytes. And then we're going to use the reduce operation to reduce this stream of streams into a single stream. I might actually replace this with map multi just for fun. And the final thing we do is we can convert the stream into a list. So that's how it runs. Here's the rot13 algorithm in case you care. So let's take a look and see what happens when we run this test. So you can see for 1,000 words, which is small, the sequential array list version is the fastest. So parallelism doesn't really bias anything when n is small. But we kind of knew that already. And by the way, Q, which is rot13ing things, is also relatively not that much computation. But we're just doing something fun. I could uppercase it too. And you'll notice that the array list, sequential, and parallel are fastest, followed by linked list. So that matches, I think, our intuition of how it should work. Now let's basically take the number of words times 10. So now we have 10,000 words. So first we did 1,000 words. Now we do 10,000 words. Array list parallels working well. Linked list parallels working well. You can see that n has gotten big enough where we're getting an n times q benefit from parallelism. And then linked list and array list sequential are roughly the same. And then down here, you can see that as it gets bigger, the array list is really starting to dominate, which again is what we'd expect, followed by linked list in parallel. And once again, linked list and array list for sequential are roughly the same because they're not really doing partitioning in that sense. And then finally, when we get all the words in Shakespeare, which is looks like 900,000 words in Shakespeare, once again, as expected, array list is dominating in parallel, followed by linked list in parallel, followed by the sequential. And I think the thing that's most interesting to notice about this is that the sequential versions are very close together in terms of their performance because they're not actually partitioning anything. They're just sequential, so it's just going through. It's just walking through the list and doing the work. Whereas for array list, you can really see the benefit that comes from splitting evenly and efficiently with the array list splitterator versus the linked list splitterator. So we're still getting a win from parallelism, but array list it's not quite twice as fast, but it's significantly faster. It's probably like 40% faster than linked list, which is what we would expect. So that'll give you a good idea of why, when you can, you're probably better off picking the array list as the means for parallel streams as opposed to linked list because it splits more evenly and efficiently.